Okay, welcome back to the unit one. Maybe this will be our last lecture for unit number one. So we were discussing about break-even analysis, break-even quantity, fixed cost, variable cost, contribution margin in our previous lecture. So here one or two examples. With that, I am going to wind up the unit number one. So in this example, the initial cost of the machine A is given rupees 12,000, and the unit production cost of the machine is rupees 6, means that is variable cost. For other machine B, the initial cost is initial cost is rupees 48,000. Initial cost means we should assume like it is a fixed cost. So fixed cost machine A is 12,000. Fixed cost for machine B is 48,000. The variable cost for machine A is 6 rupees per piece, and for machine B it's a 1.2 rupees. Okay, do the break even analysis. So we have a total number of what is a fixed cost for machine A and machine B. Similarly, variable cost for machine A and machine B. So consideration here, if we have only thing, next question will be quantity. But assumption is at particular break-even point, total cost of machine A equal to total cost of machine B. So we'll be using that relationship here to solve the problem. So total cost, particularly at the break-even point, okay, total cost of machine A equal to total cost of machine B. What is total cost? Fixed cost plus variable cost. So fixed cost is given for each including quantity. So with that we could able to achieve this relationship. So Q will be fixed cost of second machine minus fixed cost of first machine divided by variable cost of the first machine minus variable cost of the second machine. So every details are given. 48,000 minus 12,000 divided by variable cost of machine A is 6 and 1.2. With that we can able to get 7,500 pieces. This will be it if production does not exit the 7,500 pieces. It is more economical to produce to purchase machine A. If quantity is greater than 7,500, better to go with what to say machine B. So this is the similar kind of problem which we solved in the last lecture also. So another, in order to choose the process, the previous one we discussed about between machineries, which machine, whether automatic lathe machine or capstan lathe machine, like two different machines are there, machine A, machine B. So one with a different in terms of cost, but purpose is same. Similarly, in order to choose between processes, which process will be we can able to do. Yes, of course, one thing can be done with the casting process also. Something can be doing that can be done in milling process or machining process also. So n number of processes are there. Which process we can able to choose out of multiple process where we'll be started getting profit, or which is economical way, viable way for our industry. We need to decide. So for that also we can do the break-even analysis. For a given job, more than one manufacturing process may be used. The most economical process is that which gives the lowest total cost per unit. So that is what most economical process means. That particular process is going to give us cost as lower total cost per part. Then it is called as a better or economical process we can. So various notation, total number of cost, method A, method B. Similarly, variable cost for method A and method B will be there. So again, the relationship similar like machineries, total cost of machine A equal to total cost of machine B at break-even point. Similarly, at break-even point, total cost of process A will be equal to total cost of process B. So with that, the relationship will be total cost of A minus total cost of B, means fixed cost of machine A or process A minus fixed cost of process B or machine B, divided by vice versa, process B minus process A. So with that we can able to easily calculate which process going to cost us cheaper. Okay, so aircraft example is aircraft flap noise rib can be produced either by hydro press or by steel draw die. So using die or using hydro press process. Two processes are there. Through that process, we can able to make the aircraft flap. Okay, so which process? The following data is available at particular quantity of aircraft flap nose rib is 500. So for process A, they have given PA equal to, that is variable cost. Assume like it's a variable cost or process cost is 8 rupees, 8.4 rupees. Then for other process like a steel draw for die process, maybe it's a 14.8 rupees. Then total cost for high road press is 6,480 rupees. But using dyeing process, the total cost is only 16,600. Well, not 6,000, 1,616 rupees only. So determine quantity of production at break-even point and tool unit for method A and method B. So the same relationship. So quantity of production at break-even point, the equal Q equal to total cost of A minus B divided by how much the variable cost of B minus A. So we can able to get the quantity like here is 7,600 pieces we can able to do, and n is given like a 500. So by fixing by calculating this, we can able to get like CA for process A and CA for process B. So if we with that we can able to get the equation like what is CA and what is CB. So we can able to choose which method at break even quantity, which method is better to go. Okay. Then another example, a Tafe tractor company has extra capacity that can be used to produce gears that the company is now buying for rupees 100 each. Okay, buying rate is 100. If Tafe makes the gear, the company itself makes the gear, it will incur material cost of 30, labor cost of 40, variable overhead charges of 10. The annual cost associated with the unused capacity is rupees 80,000. Demand over the next year is estimated like a 40,000 units. Would it be possible for the company to make that? Yes, assume that the unused capacity has no alternative use. So from that, the previous discussion itself, we know that once we invested, if we are not utilizing that fixed cost of fixed machineries, it's again cost to the company. Here they clearly given unused capacity has no alternative use. It is not being used. So what to do? Whether to make or buy. So buy in the sense how much they given like a rupees 100 per unit. In order to make in the sense total cost, what are the things? We need to consider the material cost, we need to consider the labor cost, we need to consider the variable overhead cost. So put together we have and also we have a fixed cost of 80,000. The component we need to make is the 44,000 rupees. Make by decision. Cost to make. What is the cost to make? Variable cost only. So combination of all material cost, labor cost, overhead cost will be rupees 80 per unit. Total variable cost is 4,000 component. 80 into 4,000, 3 lakh 20,000. Fixed cost is 80,000. So total cost to make is fixed cost 80,000 plus variable cost. Total variable cost for 4,000 component with 80 rupees per unit means 4 lakh rupees. If we buy that, purchase cost, buying cost rate is 100 into 4,000, we have a 4 lakhs. So total cost to make is 4 lakhs. Total cost to purchase also 4 lakh. But one more condition we should understand is unused capacities or machineries in our industry not having any alternative plans. So the 80,000 is there now annual fixed cost that also needs to be added along with the cost of buying. Cost of buying means 4 lakhs. Along with that, this fixed cost of 80,000 also needs to be added. So total cost to buy is not 4 lakhs, it is 4 lakh 80,000. If we make, we get only 4 lakhs. We need to spend only 4 lakhs. But if we buy, even though we are spending or giving 4 lakhs to the vendor, but unused equipment also cost to us, so it will lead to 4 lakh 80,000. So the total cost to make is lesser than the total cost to buy. Therefore, making the gear is advantageous than purchasing it. Okay. Similarly, they have so this is example for make or buy decision. Here we saw like a process A and process B, which process is better, and we saw two machineries, machine A and machine B, to do the particular product. So which machine to do of for total number of quantity of something, machine one may be suitable. For some number of product, machine two is better. Similarly, we have three machine A, B, C, D. Each machine its own fixed cost. 1,000 rupees for machine A, 2,000 for machine B, 6,000 for machine C. Each unit also, each machine need variable cost per unit is 30,000, 30 rupees, 20 rupees, 10 rupees. So fix then total cost for each machine is calculated for machine A, machine B, machine C. Machine A. So by doing this, we can draw all the things. So up to some point, like a break-even point here, machine A can be used up to volume number 100, but machine B can be used up to 400, means 100 to 400 range. If you want to make 100 to 400, if you want to make, better to go with the machine B. If greater than 400 units, if you are making, then we need to go with the machine C. So here is the line cost in terms of rupees, total number of quantities being made. So the total cost we can able to draw as a line. The first one is A. Second, that machine A 16,000 is 16,000. Machine B in terms of blue color line. So here is the initial investment is 2,000. First initial for machine A is 1,000 and 2,000 and 6,000. From this 1,000 starting point with the 16,000 it goes on. So machine A, machine B starting is 2,000 and up to 12,000 machine B. Then start point is 6,000, but total at the end is 11,000 only. So by drawing that, some interaction is happening, right? This interaction point tell us this quantity is good for up to for machine A. From here to here is good for machine B. Within this range, what are the numbers coming? Better to go with the machine B. Then behind the point, if you want to make, then we should go with the machine C. So this is also one of the example for break-even analysis. So with that, I like to wind up unit number 1. So